2.5 Systems of Equations, Solving by Elimination. So we've already graphed systems and found the solution by graphing and finding the intersection that way. We've done it by substitution. The third way we're going to look at solving systems is called the elimination method. It's also called the addition method, and that's where, when possible, you can add two rows together and eliminate the variables. So looking at this example here, we see that 2x plus 5y equals 19 and 4x plus 3y equals 24. If I could make this a 4 and a negative 4, I could add these two rows together and eliminate those rows. So I'm going to multiply everything through on the top row by negative 2. 2x becomes negative 4x, 5y becomes negative 10y, and 19 becomes negative 38. Once we multiply everything through by 2, this gets multiplied by negative 2, and this gets multiplied by negative 2. Now we can just add these two rows together, and negative 4x plus 4x goes to 0. So we've eliminated the x's. And then negative 10y plus 3y is 7y. And then that gives me the negative 7y. Negative 10y plus 3y gives me 7y. And then that gives me negative 38 plus 24 gives me negative 14. And when we solve that, we get y equals 2. And I'm stalling this. Notice this example that I had pre-made has x equals, and that should be y equals. So y is 2, not x. So let's fix this. So this would be 2x plus 5 times 2 equals 19, which would be 2x plus 10 equals 19. Subtract 10, subtract 10. 2x is equal to 19 minus 10 is 9. So x is equal to divide by 2, 9 halves. So sorry, that's a bad example. So I will fix that before I make copies for y'all. But the video, sorry, it's a little messed up. So we're going to skip that example and let's move on to number 1. Number 1, if you notice, we have negative 3y and positive 3y already filled in for you. If I add these two rows together, I eliminate my y's. I get 0y. But 2x plus 2x becomes 4x. And then equals, and 2 plus 6 becomes 8. And now that's an easy equation to solve. We divide both sides by 4, and we get x equals 2. Now we have half of our answer, 2 comma, that's the x, I need the y. So we're going to take that 2 and plug it into either row, it doesn't matter, the original row. So I'm going to take the top row. 2 times x, which is 2, minus 3y equals 2. So 4 minus 3y is equal to 2. Subtract 4 from both sides, and negative 3y is equal to 2 plus negative 4 is negative 2. Divide by negative 3, divide by negative 3. We get y is a positive 2/3. Oh, sorry, there. On number 2, I notice adding won't get rid of any letters. That'd be 4x, would be 7y. But if I multiply one row by negative 1, which will just change all the signs. So I'm going to take the second row. It doesn't matter which one, but that'd make that negative 2x minus 3y equals negative 6. All I did was multiply by negative 1 on that second row on both sides. The top row I'm going to leave exactly the same and just move it over so I can add these two rows together. And when I do that, x's go away this time, and 4y minus 3y is 1y, which is just y, and 7 minus 6 is 1, so we get y equals 1. So in my solution, y is 1. And so now if I go back, let's use the top row, 2x, plus 4 times the y that we just found equals 7. So 2x plus 4 equals 7. Subtract 4, and that would give me 2x equals 3. Divide by 3, and x is 3, divide by 2. 3 over 2. So x is 3 halves, and y is 1. Now, on yours, I think we space this out a little more, so this is actually the next page. But let's look at this example. Hopefully this example is better than the last one. I found the pre-made examples, and they weren't the best choices, apparently. This one, none of the letters are the same, and I can't get them the same right now. So I either have to make both these x's be the same number, so you multiply both rows on this one, or multiply and make the y's the same. Well, these are 6 and 8. The smallest number that 6 and 8 both go into would be 48. So I don't want to go that big. Let's do 3 and 5. I can make those both 15. So I'm going to multiply the top row by 5. That'll make that 5 times 8 is 40x, plus 5 times 3 is 15y, and then 5 times 41 is 205. On the second row, if I did just positive 3, then I'd have positive 15 and positive 15. So I'm going to multiply by negative 3, and that way I'll have a positive 15 and negative 15, which will make them easy to add together. So negative 3 times 6x would be negative 18x. Negative 3 times 5y is negative 15y, and negative 3 times 39 is negative 117. And now if we add these two rows together, it's what you see why it's called the addition method also, but it's also called, oops, I dropped my pencil. It's also called elimination, because if we add these together, that goes away. 15y and negative 15y is 0y. 40x and negative 18x is, what is that, 22x equals 88. Divide both sides by 22, and you get x equals 4. Once we know what x is, go back to any one of the original equations. So I'm going to use let's use the top row again. 8 times x, which is 4, plus 3y equals 41. So 32 plus 3y equals 41. Subtract 32, and you get 3y is equal to 41 minus 32 is 9. Divide by 3, you get y is equal to 3. And x was 4, y was 3. Okay. So let's try example number 3. If I look at these rows, 4 and 3 will not add to 0. 3 and negative 4 won't add to 0. But I've already got a positive and a negative, so if I just make these the same number, and the smallest number that 3 and 4 both go into is 12. So I want to make the y's become a 12. So I'm going to multiply the top row by 4, because that would be 3 times 4 will give me 12. I'm going to multiply the bottom row by 3, because then I'd have negative 4 times 3. So everything on the top row gets multiplied by 4. So that becomes 16x plus 12y equals, don't forget to multiply the other side, which is 32. And the second row I'm multiplying by 3 would be 9x minus 12y equals 18. And now I can add these two rows together. 16x plus 9x is 25x. My y's go to 0, and 32 plus 18 is 50. Divide both sides by 25, and you get x equals 2. So my solution is 2 comma something, so I need to figure out the y value. So let's go either the top row or the second row. Second row is negative, so let's just use the top row. It doesn't matter which one. It works in both situations. So 4 times that x plus 3y equals 8. So 8 plus 3y is equal to 8. Subtract 8 from both sides, and you get 3y is equal to 0. Divide by 3, and you get y is 0. And on the next one, let's look at this one. I have positive negative here and positive negative here, so it really does not matter which letter you solve for. Let's get the x's this time, because we did the y's last time. So I'm going to make these both be 15s. So I'm going to multiply the top row by 5. I should write that above it. And the bottom row I'm going to multiply by 3, because then I'd have negative 15 and positive 15. So top row by 5. 5 times every term becomes negative 15x. 5 times 7y would be 35y. 5 times 1 is 5. On the bottom row, if I multiply by 3, I have 15x. 3 times negative 2y is negative 6y. And 3 times 8 is 24. Add these two rows together, and negative 15x plus 15x goes away. 35y minus 6y is 29y equals 5 plus 24 is 29. Divide both sides by 29, and we get y equals 1. So in my solution, something comma 1, I just need to figure out the x. So let's go plug that in, and I'm going to use the bottom row this time. So that's 5x minus 2 times 1 equals 8. So 5x minus 2 equals 8. Add 2. Add 2. 5x is equal to 10. Divide by 5. Divide by 5. X is equal to 2. So 2 comma 1 is my solution. And like I said, you could have plugged it into the other one also. If we plugged 1 in on this one, we'd have negative 3x plus 7 times 1 equals 1. Subtract 7 and negative 3x equals negative 6. Divide by negative 3, you still get 2. And that's how you do systems of equations by elimination. Now, if you can still end up with a no solution and an infinite solution, but those are still the same procedures as before. If you get a true statement, like that has no variables, then it's infinite solutions. If you get a non-true math statement that has infinite, or not a non-true math statement with no variables, then it's no solution. Good luck.